the sum of infinite geometric series. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. An infinite geometric series is the sum of an infinite geometric sequence. An infinite geometric series is a series of the form. We could remember of the general term formula and rewrite this series in this form, in which a sub 1 is the first term and r is the common ratio. Now consider the following infinite series. In the A series, the first term is 4 and the common ratio is 3. Let's find the 6th term, the 10th term, and the 12th term. We notice the greater the term number in this series, the greater the value of the term. This series would have no last term. If we try to find the sum of all terms of the series, the answer would be infinity. Series like this is called divergent series. So when we have a divergent series, there is no sense in asking the sum of all the terms. In this type of series, we ask to find a partial sum of the terms, like the sum of the first 5 terms, or the first 7 terms, and so on. Mathematically, we can write in symbols as when the common ratio is greater than 1 and the term number becomes very large, the value of the term becomes infinite. Then, if we add the large numbers, we will not get a final answer, and their only possible answer would be infinity. In the B geometric series, the first term is 1/3, and the common ratio is 1/3 as well. Let's find the 6th term and the 10th term. We notice the terms get smaller and smaller as n increases. This series would have no last term, so when n becomes very large, the nth term approaches 0. Series like this is called convergent series. Mathematically, we can write in symbols as when the common ratio is between -1 and 1, and the term number gets very large, the value of the nth term and the common ratio raised to the power of n approach 0. If we take a formula for the sum of a geometric series, we can cancel out r raised to the power of n, and we get the formula for the sum of a convergent geometric series. This formula means that as you add more terms, the value of the sum changes very little. The sum is approaching some constant value as n gets very large. Consider the geometric series. Find the sum of the first 9 terms. This is an infinite geometric series with the first term equals 2 and the common ratio equals 1/5. Since the common ratio is between -1 and 1, this infinite geometric series is convergent. But we have to find the sum of finite terms. So we take the formula for the sum of the first n terms of a geometric series. We substitute the known values into the formula and perform the calculations. Find the sum of the first 10 terms. We will make the same as we did before, but now we will replace n with 10 and perform the calculations. Find the sum of the infinite terms. Since this infinite geometric series is convergent, we use the formula for the sum of an infinite geometric series. Replace the first term with 2 and the common ratio with 1 over 5, and perform the calculations. Now, see the values of the partial sums of this series. They are very close. As we add more terms, the value of the sum changes very little. I put this example here because many students ask ourselves, how can we find the sum of the terms of our infinite sequence? It's impossible to add up all the terms. There are an infinity of them. We do not need to worry about how many terms there are. There are infinitely many, but we can see as we add more terms, the value of the sum changes very little. So the sum is approaching some constant value as n becomes very large. In this example, the sum is approaching 2.5, and the formula for the sum of an infinite terms works very well. A ball is dropped from a height of 9 meters. The elasticity of the ball is such that it always bounces up 1/3 the distance it has fallen. Find the total distance the ball has traveled at the instant it hits the ground the 5th time. The ball bounces in a vertical line and does not move sideways. On each bounce after the first drop, the ball moves both up and down and so travels twice the distance of the height of the bounce. So we must multiply by 2 the height to find the distance traveled. We can write that the distance traveled is the following series. All but the first term of the series are geometric. The first term from the geometric series is 6, and the common ratio is 1/3. The distance is 9 plus the sum of the first 5 terms. Find the distance traveled by the ball before it comes to rest. The distance is 9 plus the sum of an infinite geometric series. Replace the first term with 6 and common ratio with 1/3 and perform the calculations.